Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. In the last tutorial what we did was we did texture loading, so now we can load textures into our game. And now it's time to start getting into some higher level engine stuff. So we have some of the low level stuff done. We can display graphics. So the next logical step is to bring it up a level and start doing some of the abstraction layers that we will need to make it simpler to code in our game engine. So I will be talking about entity component system, and this will hopefully be better than the last tutorial that I did on this because I will actually be discussing the different types. I didn't know much about it last time I recorded the tutorial, but I've researched it a bit. We're going to be doing most of the same stuff that I did in the last one, but I will explain how you can do it differently if you would really like to. So let's see what entity component system is and the different types of things that you can do to code it. In order to understand where we are now in terms of the entity component system, we sort of have to go back in time to the beginning, when we first started doing game programming and programming in general. So in the 90s, OOP, Object-Oriented Programming, was huge, and it was considered the de facto standard for creating good programs. And so people would create these large hierarchies that went very deep and started with something like an object. And then so in terms of a game, we would have like an object, and well, we could have a UI or we could have GameObject. Well, GameObject could be a player or it could be an enemy. Well, an enemy could be a certain type of blah blah. UI, we could have a text or a button. Well, we have several different buttons. We have several different types of text, and so on and so forth. This gets very large, very complicated, and does not end up helping 100% of the time. It's just not good. So we sort of moved on from this approach. I'm guessing that probably in the early 2000s they started coming up with this component pattern. So once the hardware started catching up and we were able to do things faster and easier, we decided to start doing it in a different way. And so the component pattern is basically you have a game object, which is just a generic object in your scene, and this has a list of components. And so the game object only contains something that every game object would have, which is like a transform and possibly a name. And so that basically means the transform is its position and size and everything, and then a name is just whatever the game object has. So then you basically just give it this component, which is another very abstract generic thing, and a component can literally be anything. So then you put all your pieces of logic for different types of things game objects can have into these components. And so you make this very wide hierarchy instead of very deep hierarchy, which is good. And so you have like a player component, you could have, in our case, a Goomba, a sprite, a collider, a font. And there is cases when it's okay to go a little bit deeper. Like in the case of a collider, I've found that it's easier to go one layer deeper and then have like a base collider that is also, you could have a box, a circle, or a triangle, and so on and so forth. But I think 3 or 4 layers is probably the deepest you should ever go with your hierarchies, because any deeper than that, and it poses a problem. But game developers started to see a problem with this approach as well. So if you are creating components willy-nilly everywhere, say you are going through your initialization phase and you're just starting to create components. So you create your game object, gets stored in memory here. Say you create a component, gets stored here, create another component, gets stored here. And so this is game object 1. Then you start creating game object 2, gets stored here, component 2 gets stored here. And this is like the best case scenario in memory. Typically, these would be getting placed in wherever they could, not like this. And then say you added another component to game object 1. Well, all of a sudden you have this gap. And this is memory fragmentation a little bit, but this is also conducive to cache misses, which is the big problem. So what you end up getting is you get these things scattered throughout memory. There is no logical pieces to this. And so what ends up happening is when you're looping through all the components for game object 1, you're actually having to go jump from memory to here, and then like somewhere over here. And that can actually cause some performance issues. And so this is something called a cache miss, because typically the CPU will try and load all the memory that's relevant into memory currently, and then it can draw it. So if the memory is physically closer, then it will run faster. But it has to load memory that it doesn't think it's going to be used into longer term memory over here, and then it can take longer to get that. And so when you start creating objects and components just anywhere, then you end up giving a very good opportunity for all these cache misses. So they came up with another design to fix this called data-oriented design. And the whole goal of data-oriented design is to break up your components into logical groups. So you would have all of your render components, all of your sprites here. You would have all of your block colliders. You would have them all in just a big array. All your game objects. So like this is just like your transforms. You would have them all in a big array. So you would keep all of them in logical arrays together. That way your memory looked more like this, where you had just big blocks where all the components are right next to each other. And you would have all the different types of components right next to each other throughout here. Which means that now your memory is very local, it is all close together, and you will reduce those cache misses. Then, instead of having an actual game object, you could have a game object, but typically what they start to do is they have these IDs. And so say ID 0 would give you a map to every single component that it has. So it would say, okay, it's index 0 in the transform, index 0 in the collider, index 0 in the sprite, and then so on and so forth. And each of these IDs would map to all of the different components that that game object has so that you can look them up whenever you need to get them. But they thought, you know, we can do this even better. This isn't just the best design. There is still another better way to do this. Because typically, in games, you end up having these systems that end up using the same components over and over again. They have to get a hold of the 3, 4, 5 different components, and then all the other systems just need a few different components, and they don't typically interact with other ones. So this is where entity component system comes in. Instead of just having an entity and a component, you have these systems which typically need to grab the different components that they are controlling. So say you had a physics system, this would grab the rigid body, the collider, and then maybe some other stuff that is attached, the material, because it needs to know how bouncy it is or something. And then what you would do is you would store all of these in arrays next to each other. So the rigid body, block collider, and everything would be stored in arrays right on top of each other so that they are local. And then you would have something called a physics system. You could or you couldn't, it just depends on what you want to do. And the physics system, you could go directly to it and say, hey, give me the rigid body for the guy that I'm currently on. And then the physics system will go and index into the rigid body for your ID and give it directly to you, which reduces the need to go even farther out into memory. And then you do the same thing for rendering and for AI. So rendering, you would need sprites, you would need fonts, you would need textures. These are all different components that you could group together. For AI, you would need pathfinding, you would need enemy classes, you would need damage classes, weapon classes, all that stuff. You would put them all next to each other. And this increases your performance even more. However, there's a problem for us because we are coding in Java, and Java is a garbage collected language, which means that we have no control where these things get placed in memory. You can control it to a certain degree, I say, but not really. Even if you create arrays like this, one after the other, you have no guarantee that they will end up in the same memory space right next to each other. So for us to be thinking about ECS and to be thinking about data-oriented design, it's stupid. We can't do it. If we were going to move into a lower level language like C++, where we could say, give me a block of memory that's a gigabyte wide, and I will manually dictate the exact layout of this memory, then we could employ this technique, but we just can't. So we will be sticking to the entity component pattern because it's the only thing we can really do in Java. We have one more problem that comes along with this. Communication. So communication between components. I sort of talked about data-oriented. You have this ID, but still there's one more problem. How do you know when all the components are attached to the game object? So you have your game object, right? And it gets created. But say your rigid body needs control of a collider. When should it ask for a reference to that collider? When does it know it is there? And so the thing that I've typically done, which has worked fairly well, is this little life cycle thing that I have right here. And so basically I ask the question, is the scene currently running? If it's not, it's easy. First, we create all the game objects, and typically in an initialization method, so this would happen in it. Then for each game object, what we do is we add all the components. So we just keep adding components, adding components, adding components. Then we start all the game objects. So we know all the game objects have been added because we've loaded the level or something along those lines. So then we call this method called start. on each of the game objects. And that start method goes through each game object and calls a start method on the component. Then that component can call get component for another component that needs. So if the rigid body needs the collider, it would say, give me a reference to collider inside of this method. Because it knows once it's inside this method, all the components will have been added. We will guarantee that. So this is where we would call for those references. Then we run the scene. What if the scene is running though? What if we're dynamically adding components at runtime? Well, typically I found you don't add or remove components at runtime. It does happen. I'm not going to say that it doesn't, but typically what you're doing is you're creating game objects or removing game objects. And so in that case, it's still pretty relatively straightforward. What you do is you create the game object first, then you add all the components just like we did. Then you add the game object to the scene. And once we add the game object to the scene, we basically say, okay, is the scene running? If it's not, then we don't have to worry about this. But if it is, we'll start the game object here. And then we'll do this thing again where it basically just says, okay, start the game object. And then for each component, start the component. So that's how you deal with that issue, because when we're editing levels and stuff, the scene is already going to be running and we're going to be adding and removing game objects at runtime. So we must do it a little bit differently. But in terms of adding and removing components dynamically, it doesn't happen too often. Typically, you will know exactly what components you need for a game object at the object creation. It's rare when you don't, but if you do, you can come up with a special case just for that. And you don't even know if that component's going to need a reference to other components too. So it could be easier, it could be harder. But this is the approach that we will go through. So now that we sort of know a little bit about ECS and the different methods, and if you guys are programming in a different language, I highly suggest you try and do data-oriented design because it should increase your performance. I will have some reference articles too so that you guys can read up more on that in the links below. But let's code this system real quick, well, this pattern real quick, and get it working in our game engine. If you've watched my geometry dash tutorial, then this is going to be very familiar. I'm just going to run this real quick so we can see where we were at. Now, let's go into our Jade package. And inside here, I am going to create a new class called GameObject. This will be our middleman. This will be our container for communication. So we are going to create a function that will initialize this guy. And we're just going to say GameObject. And he's going to take nothing for now because, well, we can give him a name for now. But we don't have the transform data utility yet. So once we get to that, we will add that. So for now, we'll just say this dot name equals name, and then we'll go up here and we'll say private string name. And then down here, actually, we are going to also create a private list of components, just like I said, and we will just call this components. Then I am not going to import that from there because that's not the one we want. We will go into here and we'll say create a new class. We're going to call this component. And this is going to be an abstract class. So we will just add an abstract right here. And we know every component is going to need at least one method. And what is that method? Public void update with a float variable delta time. And this is abstract. So every component will have an update method that they can override. And then inside of here, what we're going to do now is we're going to create methods for adding and getting those components and starting those components. So first one we will do is get component because that's the one that's a little bit weird because of generics and everything. So what we'll say is public t extends component t get component. We're returning of type t, and I have to look at what I did the first time every time I re-implement this. So don't worry if you don't completely understand this. Just know that it does work. But basically what we're saying is we have some abstract class t, and it is of type component. So we're telling Java, hey, we're returning some type, and it's going to be a possible subclass of component. We don't know how many layers deep. We just know it's a subclass of component. And we're saying we want to take in the class that represents that same type that we just said subclass is component inside here. So that we know what component we're looking for. Then what we can do is we can say for componency in components, what we will do is, I did not mean to do that. What we will do is if the component class dot is assignable from c dot get class. So if the class that we passed in is assignable from the class of the current component we are looking at, then we will return that class, but we have to cast it. So we'll say component class.cast C. That way we get the appropriate cast, and we can also have our IntelliSense work with this, which is really nice. Then we're going to say catch the class cast exception. Oh, and we should actually wrap this in a try catch. So up here, we'll say try to return it. And if we fail, catch the class cast exception E, and we will say e.print stack trace and assert false error casting component. And I have never run into this error, so I highly doubt that you guys will too. We do not find anything that works, and the reason you shouldn't run into this error is because we're checking right here. So we shouldn't even have to do this try catch, because we're saying, okay, only if it's assignable, return the cast, but Java makes us put this catch in here. But basically, if we don't find one, we're returning null, because that is just the default that we will say. If we don't find it, it equals null, which is nice because it's nice to have that default, because there will be cases when you cannot find it. Okay, next thing that we will want to do, because this one is also kind of useful and we will probably need it, is say public t extends component void remove component class t. So same sort of method definition that we had right above there. That t object is just a generic that is of type component. Then we'll say is for int I equals 0 and I is less than components dot length or size I plus plus. And the reason I'm doing it this way is that we don't run into any concurrent modification errors, which is bound to happen, I'm thinking, with this. But we'll say if component class dot is assignable from c.getClass, same thing, where c is components.getI. So if it is assignable from that component, then we'll say components dot remove, and then we'll give it the index that we are currently on, and then we will return. That way we don't end up running into errors by concurrently modifying this loop while we are running through it. So add component and get component, or get component and remove component, both pretty simple. Last one we're going to need is add component, right? Because of course we need that add component, and we will need a start and an update methods that we can start and update these objects as well. Add component is super simple. It's exactly what you would expect. So just add component, and we will take in a component C. We'll just say this dot components dot add C. Last thing we do have to do though is say c.GameObject equals this. So we assign the reference to C's GameObject to this. So all components will have a reference to their parent, which is the GameObject, and we will make this public, and we will say this is GameObject. So just like Unity, basically upon adding the GameObject, or upon adding the component to the GameObject, we assign the reference to who this component is attached to. That way the component can then reference it whenever it wants. And we will initialize this to null, because there is no guarantee that will ever be added to a component. So we want to double check and make sure that it does get added. So that's all we have to do for adding a component. And then last thing we want to do is create a public void update method. And this will take in delta time. So this is the GameObject's update. And what the GameObject is going to do is say for int I equals 0 until I is less than components dot size I plus plus. It's just going to say components dot get I dot update. And we'll say DT. That way it can update as it's going through. And then the last method we will need is public void start. And this will just go through every component, and we'll say for I until it's less than component size I plus plus. We'll say components.getI.start. And inside of component, we'll go into here, and we will make start a concrete method that can be overridden if the subclass wants to, but they don't have to override start, because that's not a method that is actually needed for that. There we go. So now we got our start, we have our update, we can add and get components. Now we should go into our scene and implement that functionality I was talking about, where we can actually start each of the game objects and then check and see if the scene is running. And if it's not, then we do a little bit of fancy work. So we'll say private boolean is running equals false. Then we will have a method down here called public void add GameObject to scene. And we will have another method up here called public void start. And this one will be called by the window class whenever the scene has finished initializing. And this one will be called every time a game object is added to the scene. So on start, we will say if it is not running, then what we want to do is say for each of the game objects. Actually, yeah, start should be called when it's not running anyway, so we don't need to call that. So we'll say for each of the game objects, GO in our game objects list, which we will create in just a second. We'll go up here and we'll say private list game object, game objects, and inside we'll just say right up here it equals a new array list. And then over here we will say for each of those game objects we'll say go.start. So when the scene is started, we start each of those game objects. Next, when we are adding a game object to the scene, we will say if not is running, then we should actually do nothing, because if it's not running, then this start method is going to get called. So what we should actually say is only if it is running. Actually, yeah, we do want to worry about something if it's not running. So, but we don't want to start the game object because it's still going to get started in there. So if it's not running, what we'll say is GameObjects.add, and then we'll take in the GO that it passed in. If you want to add a game object, you obviously have to pass it into the function. So if it's not running, we will just add it to our list, and we will let the start method handle starting the game object. Otherwise, if it is running, we want to add it to our list, and then we want to start it immediately. That way we know that it can call and get those references if needed. So those are the two cases that we had to worry about, and they should be handled within here. And now we can add game objects and we can start it. Let's go into our window and actually start the scene now. So after we initialize, we start. And I know this is a lot of steps in our scene creation, but it is necessary and it typically does help. This is the maximum amount of steps we'll have though, because any more than this and it starts getting confusing, you have to draw out charts and everything just to keep track of when things get started and when things are called. It's just a mess. So we'll leave it at this. Now let's go back into our level editor scene and let's actually create a game object. We will just call it up here. And we'll say this game object is our test obj. And inside of init, we'll say this dot test obj equals a new game object. Test object. Okay, and then we want to add some component to it. So let's go into here, say new package components, and this will house all of our components. Let's just create a new Java class. We'll call this sprite render, something we will be needing pretty soon anyways. So let's say this extends component. We're going to import it from Jade. It's going to say we need to implement that update method. We will implement that update method, and we will say system.out.println I am updating. And inside of here, we'll say at override public void start, and we'll say system.out.println I am starting. And actually, let's just print out update on the first iteration. So we'll say private boolean first time equals false, and then we'll just say if not the first time, then we'll print this out, and otherwise first time equals true, and then we will stop printing out. That way we can just sort of see the order of operations that all this is happening in. Then let's go back into our level editor scene, and we will say system.out.println creating test, we'll say test object. Then down here we'll say this dot test object dot add component new sprite render, which takes in nothing. Then what we'll say is this dot add game object to scene this dot test object. So now we have we've created it, we've added the component, we've added it to the scene. Then down inside of our update method, we will say at the very bottom for each of the game objects, GO in our game objects, and we'll make that protected so that we can access that in here too. We'll say go.update dt. And let's go into our scene and make that game object list protected instead of what it was before. Also, right after we start it, we will say is running equals true, because we know that right after we start it, it should start running. Okay, yeah, so right after we start it, it should start running. So we'll just say is running is true in there. But yeah, so we update each of the game objects at the bottom of our update loop. And then what we'll do is we'll do one more test. So we'll say game object geo, which is our new game object. And then we'll say geo.add component new sprite render. And we'll say this.add game object to scene geo. And then we'll do a similar thing where we say if it's the first iteration. So private boolean first time equals false. And then we'll say if it's not the first time, then we'll do this, and that will fix that scoping error we have too. And I'll say first time equals true. Now that should be backwards, but whatever, it'll still work. So basically what we're gonna do is we're gonna add a game object on runtime too, just to see the order of operations for this too. And then we'll say print line creating game object, and it should be the same order. That's what I'm hoping for. So let's run this now. And we're going to get an error because we never initialized our components. So inside of here, when we are creating this, we'll say equals a new array list, just so that we don't have a null component list. There we go. And then we get it. And we see that it says I am starting creating game object. I am starting, I am updating, I am updating. Okay, yeah, so look, it says creating test object. This is exactly what we should be expecting too, by the way. So if we go to our level editor scene, it says creating test object right here. Then it goes through all this stuff, and then it says I am starting. Then it says creating game object down inside of our update loop. And then it says I am starting, and then they both update at the same time. So that's perfect. If we had moved this to below the update loop, then we would get an update, then create, then start, then another update. But what I want to show is that we get the same order no matter what, which is what we want. So if we add it at runtime, first it creates it, then it starts it. If we add it in the initialization method, first it creates it, then it starts it. All the same time, and then it starts updating. So we don't have to worry about order of operations. We have that all well and done. And one more component just to sort of rehash one of the other concepts I was trying to get at. I know this is going a little bit long too, so sorry about that. We'll create a font renderer class because that's something else that we will need eventually. We'll say extends component, and I'm going to import that from Jade, and I'm going to implement that method. Then inside of here, what I'm going to do is at override public void start, and we're going to say if GameObject.getComponent sprite render.class does not equal null. That's the last part of that. Then we'll say system.out.println found font renderer. And otherwise we'll say, actually we don't need to worry about otherwise because we're only going to have one. So if we find a sprite render, then we will print that out. And also another good thing about start, if you try and access GameObject inside of your constructor, GameObject is going to be null. And that's just because we have not assigned it yet, because there's no way we can possibly add this while it is being constructed. One of the bad things about constructors, I think everything should be handled in initialization and a start method like this, because it just clears things up. You know exactly when things are happening. Constructors and destructors kind of muddle things up a little bit. But basically, we will find the game object will not be null because we're in the start method, and then we know because it's already been created. And then we know that we will have a font render. So let's go into our level editor scene to illustrate this one. And right up at the top, we'll say this.test obj.add component new font render. And we will see that we should get found font render printed out too. So I am starting, hey, we found the font render. Then it creates the game object, says I'm starting, I'm updating, I'm updating. Okay, so we have our whole component architecture working. This is just entity component, not entity component system, but we can create components, add them to game objects. We can find other components from within one component using the game object as a middleman. We have completed this and it works nicely. And we can add objects dynamically at runtime or statically inside of the initialization method. So that's about it for this tutorial. We're going to start using this now to create some higher level functionality where we actually use this sprite render to display the graphics and stuff instead of manually doing everything inside of the level editor scene. So we can offload all of this to some different aspects of our game engine, which will be nice because then all we will have ideally is this for GameObject in GameObjects at the end of this. Okay, I hope you guys enjoyed this. If you did, please hit like and subscribe. If anything does not make sense, please leave a comment and I will try and clear that up. And I will see you guys in the next tutorial. Thanks. See ya.